me thumbs up.
Yeah.
All right, the problem for the day, find the equation of the tangent line to the curve 1 over square root x minus 5. And that's all you'll be provided. So what I did here was I took a screenshot of the graph because I advise you always look at it. And there will be something, there's calculator error, it cuts off, but this has it shoots up to infinity. So, but taking a look at the picture, understanding what's going on, we can all imagine at the time 6, 1, 2, 3, 4, 5, 6, we can all imagine what the tangent line is going to look like. Okay, we can all imagine it's going to have a negative slope. So we've got something in our mind. We're keeping that straight. So let's go ahead. I'm going to flip screens because it's not working right now, and we'll do the work over here. So let's find the derivative first. So let's make sure we've got all of our steps. The first thing we're going to do is we're going to find f prime of x. So that's our slope finding function. That's our derivative. We're going to find our slope finding function. Once we've got our slope finding function, we're going to evaluate the slope at x equals 6. And then finally, we're going to write the EQ, the equation of tangent line, tangent abbreviated line. The tangent line to the curve at that point. So those are going to be our steps. So let's go ahead and start step 1. Now step 1 is going to be a bit of a mess. Now because I'm going to use pen because we might have some issues here. All right, so let's go in and start being careful and moving through. I wonder if I've got a black pen. All right, so be very careful with my notation. So I to find f prime of x, I might be off the screen there. To find f prime of x, I need to take the limit as h approaches 0 of the following formula. So f of x plus h minus f of x all over h. Now on your test writing, on your stuff that you turn in your test, you don't have to show me this every time. I can read math pretty well. If you show me the function once you plug the x plus h in, no busy work's needed. Just correct math. So I'm going to horizontally move forward here because of screen here. So I'm going to be bringing my limit notation along every time. The limit as h approaches 0. You know I said you can be lazy and you can move your little one line down every time. So I know it's there. I'm going to plug it in. So I don't have the function. It was 1 over the square root of x minus 5, wasn't it? So then it's going to be 1 over the square root of x plus h minus 5. So that's my f of x plus h, minus my f of x, the function as it stands, so x minus 5. And all of that mess is divided by h. And if you don't mind, I'm going to delete those. I want to delete all of this up here so that we can see a little bit. We can come back to that if we need to. So then I'm going to move forward and well, before we move forward, let's see what we're actually going to do. We've got a situation here where you have the fractions. We've got a complex situation. We got 3 layers. Technically we've got 4, but we just don't write it. So we've got a stacked fraction. Now, you can do it all in one if you want. I highly advise one step at a time, just be very careful. So I would flatten the fractions, least common multiple, clear it all out, that sort of thing first. So we are going to multiply, let's do this in a different color so you see it. I'm going to multiply by a prime factor of every denominator to clear out the fractions. So what we've always done, so we're going to multiply by the square root of x plus h minus 5 multiplied by the square root of x minus 5. And that's all going to be over the square root of x plus h minus 5 times square root of x minus 5. So it doesn't confuse what you're seeing. So when I distribute this monomial, one term, to this binomial, I'm going to cancel out my fractions. So let's go ahead and do that. So let's drop down. When I multiply this factor to this term, the denominators are going to cancel, leaving me just the square root x minus 5. The square root x minus 5 times 1 is the square root of x minus 5. Then I'm going to multiply this term to the factors, and in this time this factor will cancel out, leaving me just that factor there multiplied by a -1. So that becomes -1 times, careful use of a grouping symbol, the square root of x plus h minus 5. Actually, we don't need that grouping symbol now because it's all under the radical. All over h times x plus h minus 5 times square root x minus 5. So all we did was we compressed our fraction. We have a nice simple just 2-layer fraction now. Just a little bit easier to look at. That's really what you're doing. I mean, any algebraic technique to deal with fractions, multiplying by reciprocal, anything will work. Just keep going. So now we'll come down to this line. All right. Before I do, I'm going to illustrate what I'm going to do. Maybe I can make sure I can see this part on there. I'm going to move it right there quickly. All right. So then we'll just multiply. Now it's a conjugate situation. Right. So now you've got this and this tied under the radical. This is our conjugate strategy we've used in the limits, like all up till now. So we're going to multiply top and bottom by the opposites of those. Square root x minus 5 plus the square root of x plus h minus 5. And remember, we can only multiply by 1, so we do the same thing down here. All right. I'll give time and everyone time to copy that down, even on the video, because I'm going to have to zoom back out. I wonder if I can pull back and see. There we go. It might be a little too. All right, I'm just going to do that. All right, just keep timing around. So then, let's go ahead and clean all that up. So look what you have here. You have the conjugate pair. You know, you have a plus b times a minus b, and absolutely every single time it becomes a squared minus b squared. Absolutely every time. So save yourself the work. You've done it, 1,000 times in algebra. So let's just go ahead and use that strategy. So first term squared becomes, let's just parenthesize it so you see where everything went. We squared the radical. That jumped out. The radicand came out. Then the middle terms drop out by the nature of what you're doing, multiplying by the conjugate. And then the last terms are squared. So you're minus the last term squared, which is x plus h minus 5. A squared minus b squared. So that is. all over. Now we've got a bit of a mess on the bottom. So we've got h, we've got x plus h minus 5 times square root x minus 5, and that is all being multiplied by a binomial. So bracket that, square root x minus 5 minus the square root of x plus h minus 5.
Does that not do the same thing to the bottom that it did to the top?
Plus. Say that one more time.
Doesn't that just do the same thing it did to the bottom that it did to the top?
No. It's not the same thing. It's not a conjugate pair. You know, that's a conjugate pair. That's not. Good question. This trick, the conjugate pair trick, is what you're looking for. So analyze that. Think about that a little more, and then as you do the work, and then bring those questions in like small group, and we'll go over that. We'll put some scenarios up. So let's just keep this going for the flow, and then we'll talk about it afterwards. So, let's clean it up. So you've got your x minus your x. You got your negative 5 minus your negative 5. So that add negative 5 plus 5. And then you've got your negative h. So I've got a negative h left up top. Okay, just distribution of my negative. I've got my h down the bottom. And then I've got all of this nonsense. So let's just try and take care of it now. All right, so I've got a monomial. I've got one term being multiplied to a binomial. So I've got to distribute that term to both. All right, you see it. It's not separated with a plus or minus, separated with a plus or minus. Two terms, one term. Two factors, right? The F word, things you can cancel, things like that, they're important. But no, that's what we need to keep. So let's go ahead and do it. Let's just throw this term at that term. So the x plus h minus 5, the square root of, just goes along. But this term is also multiplied, and that's square root x minus 5 squared. So radicand jumps out. Plus, so there's the plus. So now I'm going to do this one. So now guess what? This time when I multiply, this factor right here is squared. They're it's itself times itself. So it's squared. So it jumps out of the radicand. So it's x plus h, plus h minus 5 multiplied by square root x minus 5. Because that didn't have a factor to multiply with it. It didn't get squared, it's just along. And that whole thing was being multiplied by h. Now, all of this, I was lazy. It looks like I forgot my limit all the way down. Okay, limit all the way down. Haven't done any calculus yet. Haven't done a single bit of calculus yet. We're about to do it right now. So let's go ahead and remove our, factor out our removable discontinuity. Like the whole thing, right? Which one's removable, which one's non-removable. Our removable discontinuity is our h. It's a factor. It can cancel, not a term. So we got a factor. So we're going to go the limit. I'll bring my limit in later. So I've got negative 1 over, because how many h's go into h1? Over this product, right? Because I've cancelled out my h's, they're gone. So now I just have my the square root of x plus h minus 5 times x minus 5, and that's plus x plus h minus 5 times square root x minus 5. Get out of your way. Don't need that printing. So now, let's go ahead and take the limit. So let's take the limit as h approaches 0 of this number. So negative 1 over the square root of x plus h minus 5 times x minus 5. I should have just done it in one step, but I want you to think through it with me. X plus h minus 5 times square root x minus 5. So, checking along for now and just ask, like, just keep it in your notes and like ask in small group after the video, but we'll just, I want you to make a little star if there's something there. So I'm going to plug h in for 0 all the way through. So I have square root of x plus 0 minus 5. Right? So that becomes, let's just write that. I've got the square root of x plus 0 minus 5. So we just call that square root x minus 5 times x minus 5 plus a factor that has x plus 0 minus 5, so we just call that x minus 5, times the square root of x minus 5. So we're pretty much done. I mean, you could probably plug it in and move it here. Let me just give you some good algebra skills. If you get here, you're going to be good for this, you know. But well, if you get this through on the for the derivative, so you get there. But let's algebraically clean that up. So you've got negative 1 over 2 groups of, because you've got x squared minus 5, square root x minus 5 times x minus 5. So you've got 2 groups of x minus 5 times square root x minus 5. And some of you algebra beasts are like, okay, well that's a like base. That base, this base is x minus 5, and one could also write the square root of x minus 5 as x minus 5 to the 1/2 power, which is going to be very beneficial next unit, next section. So we see a base. When I multiply like bases, I add exponents. So this becomes, finally, f prime of x will be equal to negative 1 over 2 groups of x minus 5 to the addition of the exponents. This is 2 halves, because it's power 1, 2 halves, and that's 1/2. 2 halves plus 1/2 is 3 halves. Okay, now for uploading, I'm going to stop it right there. Can you stop that for me? We're going to stop that and let's do the tangent line on the second part.